Everybody wants security by design. That much is clear. It's totally clear that it makes sense to move security as early as possible to the design process of components. That was already clear when we started our research project on ICS security by design 3 years ago. But something happened in between that also increased the relevance of security by design. And that was this year. So 9 authorities at the beginning of this year, 9 international security authorities published a paper on security by design principles together. And I don't necessarily think that's important because the world needed another security by design principles paper, but it's important because it means something when 9 international authorities agree that we need something. It rarely ever happens. It happened for security by design. Now, it's a good thing, obviously, that security by design is gaining traction. But with every concept that's turning into a buzzword, gaining traction, 2 things happen. First, a lot of myths emerge. And second, more people talk about it than actually do something about it. And I would like to address both today. So what we're going to do is we're looking at 3 cybersecurity by design myths and more realistic versions of them. And also, based on the research we're currently doing, I'm going to show you a few ideas on how to actually turn that myth of security by design into a reality, how to actually get to work. Okay, first myth. Security by design is a vendor's problem. I think I'm not going to make friends with that myth in the audience here, because understandably, most of you probably are asset owners, and understandably, you think, well, we've been regulated, we're the risk owners, we've been doing cybersecurity all the time. Isn't it time that vendors take their part? And I understand, but I have to disappoint you. For ICS, that still doesn't work that way. So for ICS, cybersecurity by design cannot be a vendor's problem, and I tell you why. What is security by design? Security by design means we have a system that needs to be protected. That's our industrial control system, for example. We've got some kind of engineering workflow that leads to the system being built, being designed. That's the design in security by design. And then you have this here, the blue thing. That's this where the security decisions get made. And if you now want to have security by design, you need to get the blue into the gray, right? You need to find a way to get the security decisions into the design decisions for the automation system. And you need to do it in a way that's early enough, so before the relevant design decisions have been made. Otherwise, it's not security by design, it's too late. So, important point from this to remember is security by design always needs to build upon something that's already there. Security by design always means security needs to go into a design workflow that's already there, and it's not our job to change it. And now, when we started out doing research 3 years ago, we looked at how this engineering workflow actually looks like. Here's an example. The gray boxes are what asset owners do. And the white boxes are, in our example, it's no general workflow, in our example, are what manufacturers, here it's a manufacturer of safety controllers, do. And you obviously don't have to go into the details of all this. It can look slightly different, doesn't matter. But the important point here is there's a lot of gray in this picture. So if security by design means security needs to go into the design, into the engineering of automation systems, and the engineering of automation systems takes place at a large part at the asset owners, security by design for ICS cannot be a pure vendor's problem. The truth is that it's actually a common problem, and it's maybe even harder, a common problem of vendors and asset owners. If you want to design an ICS securely, vendors and asset owners need to develop a common understanding of the problem. So security by design is not a vendor's problem. It's not an asset owner's problem either. It's even harder. It's a common problem of vendors and asset owners. And if they need to find a common way of understanding the problem, what do engineers do? They need to find a common way for a problem. They need a common model. I promised you that we don't only must myth here, but we also show you how to get to work. And so it's time to get the paint buckets out, get the paint brushes out, we get to work, we find a common model and start with a blank sheet of paper. Obviously, a blank sheet of paper can be kind of intimidating, so that's what the first thing was we started out with. Actual screenshots here from test runs we've done. We said, okay, it's hard to build a common model from scratch when you don't even have a system yet. And it's also hard if you've got an asset owner and a vendor and they have different understandings. So we better provide some kinds of libraries. We said, okay, we provide libraries not of single systems, but of functions, function libraries. So here's an example. We said, okay, there are some kind of functionalities that most ICS need to cover. And these you can choose from the library. For example, most ICS probably need to collect sensor values and transfer them to PLCs. Mostly you have some kind of operation and observation, an engineer in a control room looking at screens. Mostly you have some kind of collection of process information, so something going to a process data historian. Mostly you have some kind of engineering of PLC logic, and this is an example here using a portable programming device plugging directly into the PLC. That was what I talked about last year. You may have some kind of malware signature distribution, you may have remote maintenance, to get the idea by now. Two important things to notice looking at those functions, and those function diagrams, in the beginning of the model that we're taking. These are very high level. So maybe getting back to what Dale said in the talk before, it's not true that you can't protect what you don't know. That's another example. You can protect what you don't know. You only roughly know what's in there. You don't know the exact components that are in there. You don't know the exact protocols that are in there. It may look completely different in the reality. But very early on during design, you can say, I need remote maintenance. And it roughly looks like this. And the second thing about this is you have all the information in there, almost, that you need for security considerations later on. You have technology, you have people. You've got interaction between technology and people, and you've got protocols and data flows between technology. One thing you don't have, and that is network architecture. So that's the second step of building that model. You selected all these functions, and then you throw everything you found in the functions into a common model. That's a network architecture model, and the only difference in here is that you add architecture information. So you see the white boxes there, that's network segments. Let's not discuss if they make sense this way, but that's one idea. And you can also, of course, show one of the functions in the context of this network architecture. So you're starting to get an understanding of what your ICS is going to look like. By the way, for this to work, you need two things. You need these human-readable diagrams you're seeing. And for this to change and to work, these different kinds of views on the models, you also need some kind of electronic data model behind that. That's a single source of truth, how you can quickly generate these models. Otherwise, you're painting all these in Visio and you don't want to do that. So, model-based security by design is the first tool that I'm introducing to you today. And for the model, that's about it. So that's about what we can work with for the rest of the session. One last notice about the model. You can, if you've got a model like this, you can actually use it for very many different methodologies that are currently out there and that are currently cutting edge. For example, INL's CIE or MIT's SDPA are both things that you can build on top of the kind of models that I've just shown here. Okay, myth 2. Security by design is done following security by design principles. There seems to be an autocomplete in people's heads saying every time I think security by design, it's automatically followed by principles. We've even seen some of these principles before here, and I'm pretty sure you've seen tons of that as well. Here are just 4 examples. It's something a colleague of mine put together for a bachelor's thesis. The thing is, these are not wrong. These are basic truths. But what are we going to do with them? Tape them to the walls above engineers' heads? And then, is that all the guidance that we can provide to engineers in order to design their systems securely? Are we just hoping that they, during their system design, have respect for the user, and then magically their systems become more secure? And that's another problem I have with principles. And that's the word principles itself. I prefer this one here. Security by design is not done by following principles, but it's done by making decisions. And it's done by making explicit security decisions during design. There's 2 keywords in this. The first, obviously, is decisions. And the important difference between a security principle and a security decision is this. For a decision, you can say no. It's perfectly okay to say, I've considered it, but I'm not choosing to do this. And the second keyword that's important in connection with that is explicit. To fill you up on this, I want to introduce you to this guy here. You probably all encountered it in the wild, looking at the control cabinet in a plant somewhere where everyone was convinced that there's no internet connection whatsoever. That's a Wi-Fi router. It's an undercover security decision. Why is it undercover? Because it was implicitly made, someone put it in there, the router, and no one was aware that they actually also made a security decision when they put it in there. And here's a number, fresh from our research. We did a test run of a security by design methodology, and we counted all the decisions that were made. 37% of the decisions that we encountered were actually implicit undercover security decisions. So 37% of security decisions were not made the way that anyone noticed there were security decisions. Okay, I promised to also get to work, so that's what we're going to do today. I told you, that's something I still owe you. I told you, okay, security principles don't provide enough guidance for security by design, so I owe you something that provides more guidance. Here you go. I've drawn a very complicated workflow that you can follow. You have a model, and then you make a decision. You have a model, you make a decision, that decision shapes your model, and in turn brings up new decisions. I'll show you how it works. And also why we do that. It's important to say, okay, we want to make all these implicit security by design decisions explicit. We want to explicitly know what security decisions can be made during design that are actually security relevant. Let's take a look at our model. For example, that function here, remote maintenance. The first and easiest and probably most elegant security by design decision is this one here. Eliminating the entire function. That, of course, is a security decision. It makes sense to take that into account as a decision and also to consciously mark that and document that as a security decision. Second, take this function here. Collection of process information. As you can see, there's just an abstract protocol saying file transfer. If we now say, for the file transfer protocol, we take SFTP, that of course is a security decision. If you choose a protocol, that may have security implications, so it should be an explicit security decision, choosing a protocol. And again, like eliminating the function, of course eliminating the function has a huge impact on your model, so the decision shapes your model and brings up new decisions, and same for the protocols. That decision shapes your model and it brings up new decisions because now you can think about how to configure SFTP, for example. Next is going to be a bit more complicated because, of course, security doesn't end at that level. Of course, there are more detailed decisions you can make from that point on. You can look at one of these entities and say, okay, there are configurations that we can make that are also obviously security decisions. We mark them by these small cogwheels in here, and we've got examples down there. This is a pretty PowerPoint slide, but these configurations can be many, many, many to consider. So you could be going through long, long lists of configurations that you would need to consider. And that, of course, is not much better than going through a long list of security by design principles. What we said is something we found that really helps is we turned those into landmark decisions. So we said, okay, we're not going to look at an individual entity, but let's first look at this entire function and ask some basic questions about this entire function that leads us through certain kinds of security decisions. So for example, it's way easier than to look at an individual programming device and say, oh, do we need multi-factor authentication or don't we? It's way easier to start one step earlier and saying, okay, for this function, how do we want changes to be made? And then you look at the individual configurations. How is resiliency of this function ensured in case of an attack? How should humans be in interaction with the function? And then you get to the more concrete decision making. So function-based, 3 kinds of function-based decisions: eliminating functions, choosing protocols, configuring function components. Should be explicit security decisions during design. And all of these decisions, you look at them, you make the decision that shapes your model, turns up new decisions, and you go from there. Next one. If you look down there, something striking you. So we've got a safety PLC and a PLC that are next to each other. You could say that's not the best idea. Let's just assume we want to change that. You could say, okay, we split it. We put an extra network segment in there. If it's a good idea or not, I don't want to discuss, but adding a network segment, obviously, is a security decision, should be marked as a security decision. Next one, up there. Probably occurred to you earlier that a direct link from the office network to the internet is not the smartest idea. So obviously, putting in security components like firewalls or also like VPN gateways or antivirus servers, that are also security decisions, should be marked as security decisions. These are architecture decisions. So, to summarize these, we've got the function-based decisions, we also got the architecture decisions. I briefly want to touch upon a third category of security decisions during design that can or should be made. And these are the life cycle decisions that are decisions that come up at a certain point at the life cycle of a component. So for example, procurement criteria obviously is a security decision you need to make, and one that you need to make early enough. Otherwise the components are procured and they don't have the security features, doesn't make sense. Monitoring of certain information, not just any security monitoring tool, but monitoring information that could be security relevant in the control system is something you need to decide at the latest when you design the control system. Can make sense to put that into your workflow. And third, obviously, a security acceptance test. When you do normal site acceptance test, it could be worthwhile considering putting security in as well. And now, if you've got these 3 categories of decision, so different decision points for functions, the red points for architectures, the green ones for lifecycle decisions, the blue ones. What you can do is, you can ask yourselves for the existing automation engineering workflow that you have, in what deliverable, in what workflow deliverable are you making these decisions? So you can tie these colorful bubbles to deliverables, workflow deliverables. And if you now know, and probably you know that, in what order these deliverables are being produced in your automation engineering workflow, you've got an individual security by design workflow. That's really all you need in terms of security by design, because again, the automation engineering workflow is not going to change anyway. And this is just an example how things could look like. The example at your site probably looks completely different, but it's pretty easy to put these different decision points to these workflow items. Time for myth 3, last one for today. Security by design is successful if after the design, no vulnerabilities emerge. That's a hard one. Because, of course, we would all like it to be true. But the problem is, first, it never becomes true, because tomorrow could always be the day when the first vulnerability emerges. And also, it's not measurable. And also, it's not really achievable, because we all know that vulnerabilities do happen. So for this, I'm not necessarily saying it's a bad goal, but it's a bad goal because it's not measurable. So we should maybe aim for something that's more achievable. And here's my shot at it. Let's say security by design is successful if after design, all security decisions we have made are traceable. So they're transparent and they're traceable by third parties. Who could be third parties? Third parties could be auditors, could be your management, could be your clients, or could be yourself in 3 years, right? Not remembering why you made a decision. So all your security decisions that you make should leave traces. Let's get to work one last time thinking about how we can actually make security decisions leave traces. And if you say, okay, we need rationales for security decisions and we need to make them transparent, probably the first thing that comes to mind is you have to make risk-based decisions. And this is a totally legitimate way of doing things. So I could say, okay, we can quickly reiterate that using our model, taking a look at what we talked about before, consequence reduction. You could say, okay, for my network model that I have here, I identify high consequence events that I don't want to happen, like a safety shutdown that doesn't work, or explosion of a reactor, doesn't matter. And of course, it's totally straightforward. It can be totally done to say, okay, let's look at a certain function. We've got the function diagram here. Let's turn to the attack diagram. What we can see in here now is we've got certain of the security parameters that we've talked about earlier, and some of these include insecure configurations that could be used as attack points, and you can use them, and when you've used them, building attack scenarios, in this example using MITRE ATT&CK based on those. So you've got a spear phishing attachment, you've got some kind of lateral movement, you've got manipulation of control, and boom, there's your high consequence event. Going through that quickly because there's nothing new. Of course that can be done. Of course that's something you can also model and that you should model, that makes sense to model. It's totally worthwhile to have that in your security decision base. You can regard your security decision base anything and everything that helps you making security decisions after all. So all of the kinds of decisions that we looked at, everything that helps you making these decisions goes into a decision base. And risk-based is only one pillar of such a decision base. There's also a second one that's very popular in software engineering and almost forgotten in OT security. That's goal-based. And goal-based is pretty simple, so you define security goals, right? But the challenge is defining security goals that actually help you make security decisions in the end, because that's the only reason why you would be interested in defining security goals. And we found, actually, here's 4 examples of security goals that we defined in our test runs. These are things that actually asset owners came up with when we asked them, do you have a security wish list? What do you want to achieve with security in an ideal world? These are things that they came up with. And what we see here is these are not all the things that a conventional security professional would come up with, because they tend to always formulate goals in terms of integrity, availability, and confidentiality. And if you, for example, take this goal 3, control system components can only be accessed read-only from external networks. That's a really concrete goal, and it's something that helps you way better to actually make a security decision later on than if you would have said, I want integrity of control systems components, for example. So that's something to consider. And actually, interestingly, if you do both, the risk-based part and the goal-based path, they both tend to turn up completely different results, so it's worthwhile doing both. Then, of course, there's a third thing that should go into your security decision base, that's compliance. If there's any regulation or standard that you need to comply with, that obviously affects your decision. I don't need to go into that too deeply, I think. And then there's the fourth one, functional requirements or functional restrictions. And for that, it pays off to go into our model one last time. We've got that function diagram here with an example for engineering of PLC logic in the context of the network architecture. We can turn that into our decision diagram, and what happens now is we have made all the decisions, security decisions that need to be made explicit. You see the little cogwheels in there, and on top you see the security decision base that you have. So everything that potentially helps you making the decisions. You've got security goals, you've got high consequence events, and maybe attack scenarios, and you may have standards. Let's now zoom into that function here and see what security decision traceability could look like in reality. So let's say we have a decision updating of PLC logic during operations. So you should decide if it should be possible during the PLC is running to update its logic. And of course, it could be a totally legitimate decision to say, well, let's disable that. And why? Because we've got an attack scenario leading to a high consequence that we deemed important before. And it's important to turn on this to avoid that because it played part in the attack scenario. Obviously, if you can manipulate the logic during runtime, that's something that broadens your attack surface. But in an alternative world, and in a more realistic world, the scenario could also look like this. Let's say, update of PLC logic during operations is enabled. And why? Because it's a functional requirement, it must be enabled. Security just didn't have a say in there. And here's another number from our research. We counted rationales for all security decisions that we made. And here's 57%. 57% of security decisions were made not for security reasons. Is that a problem? Actually, no. It's not a problem. It's okay. It's okay that we do have functional requirements, and it's okay that security gives way, because security is not an end in itself. It only becomes a problem if you turn that into an undercover decision, into an implicit decision. If you make that decision for reasons that are not security, and you also don't even notice you've made a security decision. But as long as you made the decision, and you make it transparent, and you make it traceable, you fulfilled the very measure for success that I've promised at the beginning. Security by design is successful if all security decisions are traceable. So you've got reasons why you made them, and you make them explicit. And here's the wrap-up of the three myths that we talked about today. So security by design is not a vendor's problem. It's a common problem of vendors and asset owners that they need to address together. Security by design is not done by following security by design principles. It's done by making security decisions and by making them explicitly. So you need a common model with your asset owners, and you need to have a workflow that makes your decisions explicit in your model. The model shapes your decisions, and you turn up new decisions that shape your model, and that goes all the way up. So last slide for today. If you remember that simple workflow that I've quoted today, I hope that security by design is something that you actually consider achievable and doable, that you also can take part in as an asset owner organization and also as a vendor organization. This is not to say vendors don't have any part in security by design. Everything that I've shown you applies to both. And I hope that you can take that, turn back to your organizations and make the myth of security by design into a more colorful reality. Thank you.
Thank you so much, Sarah, for that really interesting presentation and also debunking the myths of security by design, ensuring there are traceable steps. May you invite you to take a seat, please, for the panel discussion. Thank you. Now, I'd like to welcome the final set of speakers for our last panel discussion for day one. Let me welcome Mr. Marco Ayala again, the Director of ICS Cybersecurity and the Sector Lead at 1898 & Co. Mr. Justin Serlo, the Director of ICS Security at InGuardians Inc., will be joining this panel. And let's welcome Dr. Terrence Liu, the Chief Executive Officer of TX1 Networks. Now, moderating this discussion will be Mr. Paul Griswold, the Chief Product Officer of Cybersecurity at Honeywell. Please give them a round of applause. And as I said during the break, this is your final chance to submit questions, leave us your comments on our Pigeonhole platform. So we're going to bring up the QR code there in case you have not participated in that. And the microphones are free for you to ask questions too. Let me hand the time now to Paul.
Great, thank you so much. So it's great to be back at OTCEP for a second year in a row, and it's great to be moderating a panel after a presentation by Sarah for the second year in a row. So great presentation. As we were preparing for the panel, we asked Sarah to send out a copy of her slides just so we can have an idea what was talked about. And she said, I'll send you a PDF, but you're not going to get the full benefit without the talk track and the animation. She was exactly right. So thanks again. So as Sarah mentioned in her presentation, assets owners have a critical role in secure by design, but many times these systems that we're putting together are based on stuff from vendors. So with that in mind, how can we get vendors to disclose more about their security process, how they've done their own security by design, and put that into the products we're buying? So anyone want to start with that one?
I think a lot of it comes from the owner-operators themselves and the design requirements that they have. I think that when an owner-operator looks and makes the decisions as Sarah has recommended, that naturally starts causing engineering and cybersecurity requirements to be passed to the vendors for them to try to meet and achieve.
Yeah, that's spot on. The cyber requirement specification is really important to help draft that out. But also at the same time, I think, especially with standards such as 62443, with the 4-1, for the manufacturer, do they have a security development life cycle? And then the 4-2 at the component level is knowing what you're buying and seeing if the vendor's equipment and things of that nature are coming in a form of security by design. But as Sarah pointed out, and very well in her presentation, is that it's dual faceted, right? The asset owner has got a lot of skin in the game, as we like to say in the US. It's really on that piece of it, and I was really applauding the fact that you separated safety from the PLC side. I know that was interesting from that part, but agreed that you definitely have to come at this from two sides of it, right? Yeah.
I think we should leverage the purchasing power, because if you are a big buyer, you should be able to tell your supplier what you want to see. Maintainable operating system, don't have any unnecessary applications, and etc. We could reference, like Marco said, a revised version of 62443, 4.1, 4.2. And then we got a better product.
Got it. So that's something to bake into the procurement process and verify before the purchase.
I think it would help a lot if you would stop assuming that the other party doesn't want to do security by design. Because actually, vendors do want to do it, as we pointed out in the panel before. They've offered things to asset owners and they just only reluctantly took it. And of course, also, asset owners need to stop assuming that vendors are just going to do that without asset owners specifying what they want them to do, and also without asset owners being able to pay or being willing to pay for it. So I think if we would just stop assuming on both sides that the others don't want to do security by design and just get on one table and develop a common idea of security by design. That's why I talk too much about a common model and a common building it together. That would actually help the discussion.
I think we need to do both because our works in semiconductor world is the same. So we have the first standard to make sure that when the chip maker, they buy the machine from tool equipment vendor, the machine are without any Trojan or virus inside. But it doesn't mean for good, the machine will not be infected, right? So next, we need to define a security architecture or security reference guideline for the shop floor or for the facility management and follow the security by design spirit. So it's both. Yeah.
I just wanted to add one thing is in her slide, she also showed the power of FAT, for factory acceptance testing, and IFAT was also in there. And it's very important is that when you prescribe a cyber requirement specification to the vendor at the very front end, you still have to do your checks and balances all the way through the design to even operate and maintain. So once it gets delivered out at SAT, for example. So that was also something that was good.
The thing about FAT and SAT is, I think the reason why asset owners don't do it is not because no one told them or they don't get to the idea that they could do that, but because to do it good security, FAT or SAT, you have to have a really good idea of what you want. And if you don't have that, it's hard to test for anything. And that's the challenge in here.
Yeah, makes sense. So security by design certainly makes sense as you're deploying new systems and rolling things out for the first time. As we know in OT, there's a lot of brownfield, and there's a lot of existing systems that you're either integrating with or augmenting or things like that. How do you best apply security by design principles in a system that may be older and you don't know the security state of it?
I think one of the effective techniques we've seen is going into a brownfield operation, try to identify the functional units, the systems of the systems, the major processes in each site. And quite often in a brownfield, we can't make security decisions necessarily inside of the process without literally shutting down the process, redesigning it, redoing SAT. So instead what we often do is we'll usually try to wrap whatever those functional system of systems are with security, often using more of our network defenses where we possibly can. So that way we are inserting in monitoring, we're inserting in protection controls around these elements in these systems without necessarily taking the risk of inserting them right into the middle where they could have a much more consequential failure inside of the process.
And even for the greenfield, if you ask the organization if there are any legacy system, with legacy operating system, they always say yes. So actually, many guys, they just look into all the asset, and then they have this is new, very new, old, very old, and they could have, depends on their security guideline for OT, what is their security measure or control to protect those very old systems. For example, they install a whitelisting or lockdown to limit the usage to make sure even malware infection won't work. Or they just put all the legacy devices together and make a segmentation between the old and the new devices. There are several practices.
Marcus, is there anything to add?
Honestly, I think saying we can't do security by design because we don't have greenfield projects is just an excuse. Because, when do you have, I can only speak for Europe, but when do you have a greenfield project that happens once in a decade, once in 100 years maybe? We don't have any space to build greenfield plants anymore. So the correct answer is, how do you do security by design in a brownfield? Well, exactly the same way you would do it in a greenfield. You just take the changes that you make and make them securely and then build up from there.
And I think one thing to throw in there is fast as well. When we talk about security design, I think it's also important to think about it in several different levels. we end up having security defined at a component level, which is much more the realm of the vendors themselves providing a component that's security built into it. Then we have security by design at the process level, right, which is where the owner-operator is taking components from several different vendors, putting them together, and that's a lot of, I think, where Sarah's presentation will really focused on. And then we also have it at a more plant level or regional level, when we start talking about more regional SCADA, where we have that higher level of network components between the functional processes itself, which is where I had mentioned previously in brownfield, it's easier to do it at that higher level, at a plant level or a region-wide level for a lot of the brownfields. That's something we can do immediately without necessarily taking down the processes or redesigning the processes.
That's a really good point about the component level, because I think on the component level in ICS, on the component level, security by design, you can only do so much, because it always depends on how the component is built into the entire system. It always depends on how people are using it, and in the end, the risk owner is the asset owner, and that's why security by design on the component level is good for end-user products where it's just one product and one component, but it doesn't really work. It falls short in ICS.
Yeah, correct. It's not going to solve the whole problem, but it gives us the tools that we can actually then have decisions and choices later on. So, because if we don't have those if we don't have those security defenses in the components themselves, it's very limiting to what owner-operators' decisions they can actually make.
Exactly, and that's a prime example why we can't just take software security by design principles and just put them to ICS and everything is fine. We really need an own security by design understanding for ICS.
Makes sense. So security by design obviously doesn't come for free. There's a cost to it. In terms of justifying to leadership and things like that, what are some best ways to couch the return on investment for security by design?
Unpopular question. There's no way hiding the fact that you're going to get security for free.
Mm-hmm.
Right.
I like to put it with an analogy, maybe. Everyone knows that if you don't take care of your body, for example, don't do your health checkups and things like that, only a little time each week or a little time each month, then at some time it's going to break down and force you to take a really big investment at your health. And it's similar for security by design, because we talked about that before. Security by design, to be honest, is mostly not the big bang greenfield approach. It's mostly in the small engineering, re-engineering, and the small changes. If you take the effort to invest a little bit at a time to do the changes securely, to take the security by design into your changes, into your re-engineering, then it prevents you from, in the end, having an investment out of your control because you have a big bang, an incident, for example, that forces you to take big security investments. Rather do a couple of small investments before and not have a big bang forced investments in the end. It's a matter of control in the end.
Yeah, I think part of it as well is we're talking about integrating security into our products, into our networks, into our components. We need to remember that when we have engineering programs, we need to integrate cybersecurity professionals into those engineering programs, which is the only way we can actually start having cybersecurity discussions as part of pre-engineering efforts, passing on cybersecurity requirements to our vendors when they're coming up with their solutions or trying to sell us. So having these dedicated people that are working for the engineers and letting the engineers see these cybersecurity teams, seeing them as their dedicated resources in the engineering team, not random people in IT.
On the other hand, when we talk about security by design here, we actually talk about two aspects. One is buying security product with good security by design. And second is we deploy the product with the security by design attitude. And the first one, you have the purchasing power, so you demand a secure product. But on the other hand, implement the cybersecurity in OT, I think definitely it's top-down, right? You need support from the very top management. Otherwise, it's super hard to trigger that kind of activities. However, in my experiences, unlike the IT security product, many of times it's the OT pay for the money. And in some circumstances, actually cybersecurity is not that expensive. Consider a gigafab for semiconductor cost maybe 7 billion. How much budget on cybersecurity is the right budget? You know, today in most of the cloud and IT is like a 5% to 7% in average. If we think about the whole IT cybersecurity spending last year, it was 180 billion, where the whole IT spending is 3,000 billion. It's 6%. But for a $200 million factory or $1 billion factory, how much would you plan on cybersecurity budget? If it's a zero, it doesn't sound right? But a lot of the time, it's actually nothing there. And so for OT, you know, in my case, like a semiconductor, they buy a EUV for $100 million, right? And then implement cybersecurity. It's not just about money, but more about the whole cost on do they have the talent? And do they have the policy in place? Are they willing to work with the security guy? I see more hurdles there, not just the money.
I also think security by design, it's important to note that it doesn't actually mean we take different measures than we would otherwise. We just take them earlier, or we consider taking them earlier. Doesn't necessarily mean we're taking all of them. And that, I think, is an important question and maybe even answers part of the questions the last question that we're seeing here. Do we have any statistics to prove that security by design is worth the effort invested? Because oftentimes, security by design measures, if you take a measure, consider taking a measure earlier in the process, is cheaper than taking it later. Yeah. So if you decide from the beginning on that you want to choose a certain protocol, or that you want to eliminate a certain functionality, or that you, whatever, one of the decisions that I've shown as examples before, it's way cheaper to make it at the beginning than to make it at the end. So you're actually only talking about making the same security decisions, arriving at the same security, but at a cheaper cost because you're doing it earlier. Because everything that you have to revert later on just adds up cost. And also, it's important to decide earlier on which measures you don't want to take. So also decide early on and then have it decided and have it documented and don't have to redecide all the time when something pops up and a fancy product pops up again. Have a waterproof argument for why you don't want to invest into something. Of course, that can change if threat landscape changes or things like that, but you have the basic decision. So that, of course, is something that is an energy, time, and in the end, cost saver. Potentially. So that is probably the best argument for management and also for engineering managers, because they very well know the argument that a failure or a fault that you do early on in engineering is way cheaper than a fault that you do later on and has to be corrected. It just adds up exponentially. There are heaps of studies on that one in safety and just normal engineering efficiency studies. So that maybe is the best argument for security by design.
Yeah, and to add on to that, we've seen that in the offshore space, on the offshore platforms, where we've had rigs that were new built, didn't have cybersecurity, already going off with remediation plans, already striking first oil. And the cost to go out there and even try to find a window of opportunity to even remediate cybersecurity, there's numbers to that. Compared to new rig also going out there with security baked in, we've seen a lot of the majors be able to say, if we do it now, it's much cheaper by the millions.
Also, the measures that you can still choose in the end when everything is done are mostly the things that add complexity. You put a new appliance in that does something for security versus you're eliminating something, you're making the right decision for a protocol or anything straight away, you're putting security requirements into procurement and don't procure components that can't do what you want them to do. So these are all the things that just potentially are the less elegant solutions, are the more costly solutions, and also add to attack surface.
Yeah, it's another point is that even with the OEMs, you may have multiple OEMs within a single platform or a single site. And if you can do it up front, think about the cost of not only the appliances and the software, but also the people to go out there if you have to fly them out to go out and actually do the installation, do the setup, do the configs, finding that window of opportunity, that cost, that return on investment that the question was around, that cost is exponential to be able to do that. So it's better to bake it in up front and get it installed up front.
So we're going to take a question that came through here on Slido from Anonymous. In cases where companies operate systems owned by another company, how should the operator company go about complying with security by design requirements?
Can you read that again? I can't see it from here.
So it was where you have companies operated by other cases where companies operate systems owned by other companies. So the asset owner and the asset operator are different. How do you go about ensuring that the system's secure by design?
Yeah, I think that's a good question. So we do see that, especially offshore. You might have a drill ship where the operator is operating. And so we've seen where, from a secure by design, the boat owner or the drill ship may own the system, but the operator is ultimately responsible if there's a problem offshore. And that's just one instance. And so it's a joint effort. And typically, the operator will lean on the asset owner or the vessel owner in this instance to be able to do the right thing and follow their controls, their security controls. It's not an easy answer. It depends, right? And especially with OT, I think that I should have a shirt made that says OT, it depends. Because there's so many different situations in that regards.
I think in a perfect world, right, they would be encouraging each other and holding each other liable and responsible for trying to increase that level of security.
Yeah.
Just like what we hope that vendors and owner-operators, try to continue to raise the bar on each other as well. The problem is when we end up having a race to the bottom when each one are actually trying to go lower and lower the security to cut costs. So.
And I have two cases. One is a big pharmaceutical, and they spent several $100 million just for upgrade their Windows operating system up to speed. And on the other hand, I run into a medical center, and they have a lot of modality. So consider that's also OT, right? And the modality also equipped with the legacy operating system. And when they went to the vendor, said, "How about upgrade for us?" And they charge them, I think, like $8,000 or $10,000 per modality. And it's like a crazy for them, right? Because it's just Windows. And if you check the retail price of a Windows operating system, it's not that expensive. So instead of paying to the vendor, they just install another security approach, maybe like anti-malware or like lockdown to secure those modality. So two options here.
Okay. So another question from the audience here. What are some pros and cons for having security goals versus defining risks to mitigate such that overall cybersecurity posture can be improved? Sure. Yeah, it's not. Yeah, it's not. There's no button to put it up on the screen. Let's try that. Yeah, I'm not sure what's going on there. Let's move on to another one. I think that was a little confusing. So in Secure by Design, can we talk about a little bit of the differences for the principles in OT versus IT?
So what are some of the different principles?
Yeah,
Well, the first biggest issue is that in IT, we mostly, when we talk about security by design, we talk about software. It's also where the term security by design comes from. That's why when we Google security by design and find security by design principles, we find all the principles that I've placed on the slide before that only apply to software engineering. And if we now compare the process of software engineering to the process of automation engineering, of engineering of an ICS, I'm not saying software engineering is easy, but at least it's not 15 different disciplines involved there, right? So you don't have electrical engineers and process engineers and mechanical engineers and safety engineers and whoever, and that's already a complex process. And in the end, the automation engineers, that's a whole own domain, comes in, and they already complain. They're always late to the party for automation engineering. They're always the ones coming in when all the decisions have already been made. And then security comes in, because we're the ones are super late to the party, right? When the automation engineers have come in and they complain decisions have been made, security comes in and all the decisions have been made. And that's just a whole new level of complexity compared to software engineering. That's why the software engineering security by design principles simply fall short for ICS.
Yeah, I agree with that.
Yeah, I think not just the different fields that are there, but just even the technologies themselves, right? We, inside of an OT environment, we tend to have virtually all the technologies IT have. Granted, we're a little bit slower at adopting them, but we tend to have everything that they have. But then we have all this other stuff that is very unique to an OT environment, which further, I think, complicates the situation that's there. So,
And if we compare the MITRE metrics between IT and ICS, and you see the ICS version is with those like a function impair or like a damage thing, right? So if you consider your organization could be suffer from like a cyber sabotage, then that's the different part. Because in IT, you don't really have to worry about the explosion of the pipeline, but yeah. And on the other hand, well, a lot of security principles should be just the same, right? You like zero trust, you don't trust, you always verify. It's just a lot. There are a lot of limitations for OT, and I see a lot of organizations. You know, they craft a small team from IT team and bring out their security guideline for IT. And one by one to check it with OT guy, can this be done? Can this be done? And eventually come up with, that's their first step to extend their their cybersecurity guideline from IT to OT. But I think it's more about the casting for those limitations in the environments.
Great, makes sense. So security and usability can sometimes be at odds with one another. The most secure system may not be the easiest to use system. When you take security by design and compare it with usability, what are some things to take into consideration to make sure the secure system is also a usable system?
honestly, I think usability is one of the best ways to measure effective cybersecurity. Cybersecurity done properly should make it just as usable as it was without it. It should be fairly transparent for the average user.
Yeah.
So think of everything we've done inside of the IT world, everything we've done with our bank transfers to, communicating and doing online banking. Think of, anything else we're doing around our homes with the physical security or home automation that we actually have. Security implemented right should be done without you. You're not configuring security keys. The security keys and the crypto keys are automatically done behind the scenes when properly implemented.
Yeah. Yeah, and I think a big piece there is just from the usability standpoint is making sure, especially on the operational technology side, that any false positive from a security event doesn't lock the operator out from operating, right? Because that can create its own safety implication. And that's, to me, is the fear about implementing any type of security design, is that it's got to be able to allow the operator to operate and the systems to be able to function. Where in the typical traditional IT enterprise, locking out a user is not a big deal. Losing email for 30 minutes, people are upset about it, but losing capability to get to an operator station or even be able to actuate things, that's a problem, all right?
I have a question to answer that question. So for your home computer, which is more usable, a built-in firewall or something you have to install on top and then configure? So you have at least the chance, I'm not saying it's always easier, but you have the chance, the opportunity, if you think about security controls earlier in the process, to also make them more usable. It's not a guarantee. You still have to consider usability.
We fail as much as we succeed.
Yeah.
Makes sense. Okay, great. So you touched on this a bit in your presentation, Sarah, but software is not static. You could have something deployed with 0 vulnerabilities, and then you go on 5 days and 6 vulnerabilities pop up. So given the fact that updates, especially to the operating system, can sometimes break things or cause slowdowns or other issues with the process itself, what's the best way to think about incorporating the software update strategy into your Secure by Design from the beginning?
Actually, I think that's a patch management question, not a security by design question, because I don't think security by design changes anything about that. So it's probably the same like for all systems. So I think if you really need the patch, and if you do, then try testing it before rolling it out. So, and then, of course, again, make it a conscious decision and document why you made the decision, and that's about it. What helps, though, is if you, during design, you build up a security decision base, you build up a documentation of why you made certain decisions and why you haven't made certain decisions. If you have a workable model from a security standpoint, which is mostly more abstract than all the models you have from engineering, as you saw in the pictures up there, it's something that really helps you in deciding when making these dynamic decisions coming up later. So actually having a security by design model is something that not only helps you during design, that is something that should help you later on, or that does help you later on. I got examples for that one when you're in operations. We've got an example company, for example, that did the same exercise that I've shown on the slides. They picked all their functions and modeled their systems function-wise during engineering or doing re-engineering. It wasn't a greenfield plant, but they did that for their existing systems and said, okay, we want to do that for a re-engineering project. And then real life kicked in and they had a security incident. And the IT department called them and said, okay, we've got an IT incident, a security incident in the IT systems. Can you quickly cut off the firewall between IT and OT? And instead of turning into panic and saying, I don't know if we cut it off, I don't know what works and what doesn't work. What they actually did is, I'm not making this up, is they took their list of functions and their diagram of functions and said, okay, let's see in which function this firewall is involved. So we exactly have the list of things that won't work anymore after we remove that firewall. So it's actually something that helps you making dynamic decisions during incident response, during if you have new vulnerabilities coming up, new patches coming up, if you have done your homework during the design phase.
I think we also need traditionally, if we go back 15 years ago, we would often go ahead and we would implement a new process or a new plant, and we would design what the site acceptance test would actually be, and we'd often do that for the whole entire thing, and we wouldn't actually make subcomponent life cycles, and we wouldn't do different elements of it where we had to refresh or actually plan security obsolescence or the security updates into it. Something that I think many vendors and owner-operators are trying to do today is starting to create these subcomponent life cycles as well as these subcomponent tests that we can go ahead and complete. So if I need to update this one single component inside of this larger process, I have some type of a test to validate that update properly went into place. And we actually are creating update periods where we know this piece of machinery is going to fail, but we also know that there needs to be some type of a security update that needs to be done, or some type of a system update. Having periodic times where we can actually do that. And then I would say, when I work with the vendors and when I do penetration tests and security assessments of vendor products to market, right, making sure that they've actually planned in the need for being able to do a security update inside of their product itself. How can they actually validate that product itself? How does that affect the overall system? So if a vendor is providing a solution, that vendor should also be providing that solution with the ability to do updates on components of it without necessarily having cascading failures across everything. So I think that comes into the overall design of the components and the processes.
And that's also something where I think virtualization and digital twins and all the things coming up now can really help in these test environments, because you may not want a virtual PLC, it's discussable, it's debatable, but you can have it for a test environment for patching. So nothing against that.
That's fair.
For high-level servers being virtualized, I think it's easier to do the patch. But for like HMI, and a lot of them are based on like Windows operating system, it's hard. And in terms of patch, I think that's really not just a single question, but the whole cybersecurity posture. I mean, because some companies, they are able to do like a monthly patching, but some companies, they just don't do it. But depends on their confidence on how isolated or how air-gapped the environment is. But I think we should think beyond the patch and just a security by design thing, because in the end, what happened most is when the cyber criminals attack IT, and that specific criminal group use the ransomware to attack OT servers, and that could also interrupt the whole operation, even they don't touch the control system, because just attack whatever Windows they could reach, but there's still a OT cybersecurity problem. So I think even we do patch, but we still need to make the OT more defendable. I mean, I'm not saying we just like IT. In general, large enterprises in IT could have more than 50 different kinds of cybersecurity solutions. In OT, that may be overkill. But if we just rely on the software itself, maybe it's far from enough.
Well, I think that's part of your defense in depth, right? Being able to isolate the data that we actually need in the OT environment from the IT, isolate that and identify paths and be able to add their protection boundaries that are there. But in the OT environment itself, right, while we don't want to have to go through and patch everything, and we'll never be able to go through and patch everything inside of the OT environment because of several reasons: risk, manpower, right, validation of the patches themselves. We still need to make sure we're actually building into our processes, into our plants, into our components, right, that ability to do updates when we make the decision to throw an update at it.
Yeah, right on, and by zone.
And
right?
validate it.
Yeah, validate it and by zone. That's why I'm a big fan of zones and zoning. One of the key pieces there within the security by design is also the importance and the imperative of security by deployment, and making sure that there's also a check sheet for asset owners to be able to say, in this MOC, we are going to have security as our deployment plan. So yes, we're going to do security by design the way Sarah has shown us in her presentation, great ability of doing that, but also we are going to deploy it, and we are going to have that as a loop back to close out that MOC. Otherwise, what are we doing? I mean, in this day and age, we need to be doing security at the very front end, but also at deployment.
I think that concept zone is much, much better than just a wall. Because a wall could be easily just evade. In our, we just done a questionnaire to 450 large enterprises. And in the questionnaire, it showed that 94% when the organization's IT been hit, the OT will be impacted. And these are large enterprises. And so they definitely have a segmentation firewall sit between IT and OT. However, maybe just because of the same password, the same credential, and they use the AD connect to each other, those kind of things cannot be just segmented by a wall, but by a zone, that's, which means you are not able to talk to OT directly. It's always OT fetch something in the zone. It will be much, much, much secure.
Makes sense. So returning to the subject of vendor transparency, one of the things that's gotten a lot of attention over the past several years has been software bill of materials, and the promise of having that be more transparent in terms of what the software we're buying is actually made up of. How do you see that fitting into this process? Is software bill of materials something that can really help from a vendor transparency perspective, or is more needed?
I'm not the expert on SBOMs, but I know some people. I think it's important to have it, but is it needed? I think Sarah demonstrated in her presentation that a lot of the function of security by design could be done even, for example, at the PLC level and making decisions in your decision tree whether to do something or not, but documenting it. Some of these systems are going to be vulnerable, and so you're going to have to, make some acceptance pieces. But I think there's value in SBOM. But I'm not a vendor. I worked for a vendor at one point, but I really can't speak to it.
I mean, an SBOM doesn't solve security by design. It's just something that helps, gives you transparency. If you have an SBOM, that's for, let's say you have an SBOM for your ICS, for a component in your ICS. That, of course, gives you a really good hint where to look at what vendors you need to cooperate with in terms of security by design. So what are the biggest flags, your biggest dependencies you have? And then see how you can approach these vendors and say, okay, we would have, for our use case here, how we use your software, this is the things that we would consider important for security by design. So this is something that you can help flag the vendors which you have great intersections with, where you have to work on that common model that I talked about. And then there's also the limit, of course, because if you've got an SBOM, you've got 100 vendors where you have dependencies on, you have to pick and choose, and you probably have to accept that you can't work with all of them. But at least then you know that. So that's something that's also worthwhile, just knowing where you have problems, where you may have problems, and where your knowledge of how secure your components are and your capabilities of doing security by design is limited.
Yeah, and I would add to that saying that if a vendor does not have an SBOM for their own teams internally, then that vendor's not doing security by design by the very definition of security by design, right? Because those are the building blocks of their software code. And if they don't know the building blocks that are going into their software code, they have not made the decisions.
That's a good point.
Yeah, but that's just like in last session, when you have SBOM, how you're going to do with it. And transparency is here very, very helpful. I think when as a buyer, when you buy something, you definitely want the supplier to let you know what kind of applications been installed, what kind of patch been installed, what kind of service been activated, and with that, they can decreasing the attacking surface very significantly. But so I think that transparency is very important. And it's not just listen to the vendor, and many of the organizations we are working with, they would double confirm. So you tell me you have these applications and this patch has been installed. I'm gonna 100% inspect whatever you deliver and at their end. So never trust, always verify.
Okay, great. So we've got just a few minutes left. We'll take one more question here that came in from the audience. What are the next biggest challenges in OT cybersecurity, and how can secure by design principles help address them?
Boy, the next big issue for us, huh? Honestly, I think most of us are spending 90% of our time just trying to keep moving forward, keep trying to do what we're doing and increasing to our plates what we're dealing with. But from new technologies, we've talked about AI before in here, and really I'm somebody a little bit different, but AI to me is just really a continuation of what we already have. It's a better tool for us to be able to use. I think of AI kind of like what we think about automation inside of our industry. Automation is the process of taking components that were traditionally by humans and actually automating it. AI to me is just that next step. So, right, AI is something that can benefit us and work against us because it can benefit attackers at the same time. But honestly, I don't know if AI really is the next big thing for us. I think it's probably more of the expectations or the directions our businesses are going to try to take us in trying to chase the next business benefit or the next advantageous capability that they want to adopt in there, and we have to find some way to be able to secure it and make it a safe business decision to deploy.
And yeah, I think OT security today is already very hard. It's difficult to imagine how hard it could be in next 2 years. So think about 2010 Stuxnet, and then you have Shamoon, right? Black Energy. Those attack target the control system, and they use the vulnerability from Siemens, from Schneider. And nowadays, you don't really see those kind of attacks that often, right? They don't need to. There are so many Windows operating systems in the OT. You just encrypt it, right? Or you just destroy it, just like what you done, I mean, as a hacker, what you done in IT, right? They use the same technique to attack OT, just like IT. And recently, we saw Volt Typhoon, right? AKA Vanguard Panda, right? A China group sneak into US critical infrastructure who support telecom power to the US military bases. And it took actually Microsoft and CrowdStrike almost 30 months to disclose the group, right? Because they use live off the land, I mean, native Windows application to do the lateral movement. And think about how many software and hardware been installed in IT. And then we still blind to this kind of behavior for 30 months. And how many security product or solutions you have in OT? Then we got a long way to catch up, I think.
I think one of the things that scare me the most is, you know, the world political, you know, internation warfare issues that are going on and continue to progress. For a long time, 13 years now, right? It's a hard fact that our OT environments are the pawns of nations. And honestly, the thing that bothers me the most is we are continuing to be that, and we are being used more and more for internation conflicts and being leveraged for that, and it's just going to continue to get worse. And the fact that we still don't have any publicly disclosed loss of life directly influenced by cyber attacks still blows my mind as somebody that's been in this industry for 23 years. I still can't believe we have not seen that yet. And unfortunately, as the world politics continue to worsen, I'm just worried that that's going to be right around the corner.
Last couple of seconds, Sarah, Marco, anything to add?
I think one of the ones that keeps me up at night for the next big challenge is, you know, what was it, 2009, 2010, we were talking about SCADA in the cloud, and that became a thing. Now the big discussions around controllers in the cloud and just having remote field I/O. That, I think, is the next big challenge, is walking people back from deploying that is going to be the next big challenge. So.
I think I'll just try and wrap it up where I started in saying everyone wants security by design anyway. It's a buzzword, so it's going to come. It's going to come here in Singapore. You already have regulations on that. We have got regulations coming up with the Cybersecurity Resilience Act in Europe. There's something in the US going on as well. It's coming up, and the biggest challenge is, from my point of view, that we screw it up, that we do it all wrong. This is our chance to get security by design purposefully, meaningfully into products and into products that can be used by asset owners. And the two risks that we have is that A, we just take the security by design understanding from software and try to just put it onto ICS and it just doesn't work. And the second thing is that we make the same mistake that we're doing in regulating asset owners and just drowning them in long lists of requirements that grow longer and longer. And that way, if we do the same with vendors, then security by design becomes a hiding game between vendors and asset owners. So it always becomes a matter of, are we trying to have, for compliance reasons, have ticked off our checkboxes, but not show you, the asset owner, what we actually don't really do security by design. And it would be such a great chance to say, okay, let's not focus on regulations that have long lists of requirements, but let's focus on regulations that encourage people, asset owners and vendors, to work together on what they really need and prioritize and make decisions, as long as they document their rationales and make them transparent.
Great. Thank you very much to the panel for a very good discussion.